Hi, it's Frank Hoose from MiniLathe.com. This is part 3 of the antique clock repair video. And if you missed parts 1 and 2, you may want to go back and review those. But the basic story is that my brother, who recently retired, met a lady in their community who had a very old antique clock, but it was not running, it was not winding properly. My brother Tom, since his teenage years, has been a clock repairman. Tom is an electrical engineer by training, but he retired a while back, and since that time he's gotten active in clock repair again. So he agreed to take a look at this clock and see if he could get it working again. And as he got into it, he found that there was a winding gear that had some teeth broken off. He couldn't find a replacement. He asked me if I could repair the gear, so I brought it to my shop and worked on it and was able to get that repair done. By the time I got the gear back to Tom and his wife Jeannie were getting ready for a vacation in Germany where Tom was born. When Tom returned from vacation, he tested the new gear and was confident that it would work. So he completely disassembled the clock and lubricated it and cleaned it thoroughly.
My brother was able to repair this. There was a broken teeth on the winding mechanism here, this gear, and he was able to repair that for me, which I appreciate very much, and get this back in operation. This clock was then taken totally apart. Every piece of it was taken out and checked over and cleaned, and then I've reassembled it all, and now you see it running here.
When doing repair work on a brass frame clock like this one, a common technique is to use screw-on stands to hold the frame of the clock horizontal so that you can easily access the parts to work on them. Tom had a set of stands that he bought many years before, but they had a tendency to work loose from the frame and allow the frame to drop down onto the table. Obviously not something you want. So months before this project came up, Tom asked me if I could make him an improved set of stands, and I set out to do that and came up with an idea to make them hold more firmly. So I sent them, and Tom really liked them, and he put them to use for the first time on this project. So I'll show you some clips that Tom sent me of that work and the final result of the working clock.
This is a demonstration video of a Junghans clock movement model A20 that came from a Junghans tambour clock, probably from the 1920s time frame. Junghans is in Württemberg, Germany, and they made very high quality movements in that time frame, which you'll see shown here with all the different features of that time, advanced features for that time. This clock has three main sections. In the middle is the timekeeping section, which has the winding section here, the hour and minute hands, and then it gets gear reduced. And in the middle is what's called the escape wheel, which connects to the pendulum, and that regulates the timekeeping of the clock. Over on the right is the quarter-hour chime, and this particular clock does Westminster chimes. And again, this is the winding section, and then some cams that keep track of how many bars of music to play, and then eventually gets gear reduced down. And at the very end is a governor or a fly. It's a piece of metal or brass that is used to blow air around and controls the speed. And then on the left is the hour strike that denotes the time of the hour and has a winding mechanism, and then some cams and other features to count the number of hours to strike, and eventually goes to another governor or fly on this side. The purpose of the demo will be to show the different cams and operating features of this model. This is a very advanced clock for its time, and prior to this, clocks didn't have a connection of what the hours were showing on the hands and what was happening in terms of the strikes and so forth. So it was very common for an owner of a clock to run the hands backwards, which they should never do on any of the clocks from the 1800s, or go forward potentially, and the hand and the striking mechanism would get out of synchronization. But in the late 1800s, the clock's invention had been made of this device, which is called a rack and snail. So here is called the rack, which counts how many times to strike, and a snail, which is a cam here located on the hour hand. And because of its shape, it looks like a snail. And the snail steps one more depth for each hour. So at 1 o'clock it has the least depth, and eventually progresses over here to 12 o'clock with the largest depth, and that this rack drops down to engage this, and that determines how many times to strike, and I'll show that operating in a little bit. Most clocks prior to 1900 should not be wound backwards at all, and only certain ones after 1900 can be run backwards. But this one, I can safely go backwards. It has a special mechanism here down by the hour where it can allow the clock to go backwards. Next thing that happens is, under the normal course of running, the hands will advance, and this cam starts to lift up. There's a pin on the hour hand, hour wheel I should say, that lifts this lever, and you can see it starting to lift the lever here on the chime mechanism, and the fly is starting to turn a little bit, and right there it's now going into warning. What that means is it's gone from the lock position, and now it's ready to go into its chiming once it hits the next quarter hour. In this particular case, the quarter hour is also the same as is one of the hour ones, and it stays in this warning position until it gets to the full hour, at which point it triggers, and this cam here counts off the number of bars of music, in this case 4 bars of music for the hour, and then there's a pin that lifts this lever and drops the rack down for the number of hours, so it has 5 hours that it's going to strike. So there's 1, 2, 3, 4, and 5, and then it re-engages the locking mechanism again, and that completes the cycle for the chiming and striking on the hour. At quarter past, it goes through a similar process. It goes into warning, and then operates, but at quarter past it only does 1 bar of music and then stops.